Deploying immutable infrastructure is a fundamental practice in modern DevOps that enhances stability, security, and reliability. Immutable infrastructure means that once a server or component is deployed, it's never modified. Instead, any updates or changes require a new instance to be deployed. This approach contrasts with mutable infrastructure, where updates and changes are applied directly to existing servers. This is what we look at in Knowledge Area S5 and deploying immutable infrastructure. So I'm hoping you're going to get a lot from this. So let's begin by making sure we understand the difference between immutable and mutable. Now, as we touch upon in the introduction, with immutable infrastructure, the item doesn't change during its lifetime. So if we're talking about a server operating system, we create an image for that server operating system and we deploy the image. We never then update that image. Of course, updates are going to be required, but we can then apply them to the image offline. Once they've been fully tested, we can then go through and deploy a new instance with the fully tested updates. Now, that's different from your traditional environment, where you're likely to be applying updates to the server throughout its lifetime. In this video, we will build a Rocky Linux system as immutable infrastructure. We'll do this by disabling all software repositories once we have finished the configuration. Having built then our master image, we will package it up with HashiCorp's Packer imaging tool, adding the image to the Vagrant image library. We'll deploy this image as a Vagrant managed virtual machine. We'll be able to see that we're unable to perform any updates on it or install new software. However, when we do want updates, we can go back to our original image, re-enable the repositories and perform our updates. Once fully tested, we can then go through our packaging process again and redeploy the image. So our first step is to install our operating system. We'll be using Rocky Linux, but the idea is that we're really just demonstrating how to build an image that is going to make use of immutable infrastructure. So we do need to install our operating system. I'm going to be installing it within VMware Fusion as my hypervisor. Later on, once everything is complete, I will be managing my virtual machines using HashiCorp from Vagrant. But our first step is to create a new virtual machine. Now, it doesn't really matter the operating system that you're using or the hypervisor. We're expecting you to understand the steps in installing your OS and using your hypervisor. But I'm going to go through and create a new virtual machine. I can browse through to my ISO file. I already have an ISO file for Rocky Linux. I'll install Rocky Linux 8. Now we can then go through and just take a look at what it's showing me as far as the resources. So 2 gig of RAM and 20 gig of disk should be about okay. But obviously I could customize these settings if I needed. But I'm just going to continue by clicking, and we can go through, and I'm going to set a more reasonable name so that I can understand the name later. So I'm just going to call it Rocky_master, and then we're ready on this. With that done, then our glorious installation journey can begin and we can fire up our virtual machine. We'll run through the install, and the install is going to boot from our ISO file, but of course is going to allow us then to be able to install into the virtual machine. So we just allow it to boot up. With it started, I'm happy to leave the default here with the language set to US, so I can then continue once I get focus on it. And then as we go through, well, I'm happy to leave the keyboard set to US, the language to US, the time and date. I can customize all of this later. We're installing from the local media with the software selection of server. When we look at our system category, we've got our installation destination, and that's just marked as red. So it's going to want me to go through and check it. But again, I can go through and just select the defaults, which is going to be good, and choosing done. When we look at the network and the host name, we can see it says it's not connected at the moment. So there's a couple of things that I can do here. I can set then my host name. So I can set it to rocky.example.com. And I do need to make sure that I enable the network card, and then we can click done. This allows me to go back then to our main screen, and we can see then that we can set the root password. We don't have to, but I will set the root password. We could choose to disable the account later. And with that done, we can go through and configure it. The user creation, I'm going to be using this with the Vagrant Virtual Machine Manager later. So we need a user account that's an administrator called Vagrant. And by default, it should have a password of Vagrant. So I'm just setting this up. And we're about ready to go, so we can then continue by beginning the installation. And obviously allow this to chug on through, and we can resume once this is finished. Now, we weren't installing any graphical environment, so there's not too much that needs to be installed, so it shouldn't take that long. But then we're presented with our screen once it has finished, and we can choose then to reboot the system. And of course, on the reboot, we are now presented with our login screen, and we can log in as our Vagrant account, the account that I created earlier. Remember, I was saying then that it should default to the password of Vagrant. It's not the most secure, but it becomes the way that Vagrant uses to manage this system. But yeah, we're up and running, and we'll look now at how we can customize our image. So having installed our operating system, we now need to customize the operating system. So back working on our operating system, we should be able to customize it. We can customize it through the terminal here, but we also might prefer to connect to it remotely. If I go through and look at SS for show sockets, and then take a look at my listening TCP ports, you can see that I'm listening on port 22. TCP port 22 is SSH, so our SSH server is up and running. If I want to know the IP address so I can connect to it, I can use IP -4 A for address, and we can then see our IP version 4 addresses. Obviously, I'm not interested in the loopback address, the 127 address, but you can see there that I've got the 172.16.247.164 address. So I should be able to create an SSH connection using the same Vagrant credentials that I use to log on to this system. So moving across to my SSH client where I'm already logged in, I get the advantage that I have much more control over the font for a display purpose, but also I'm using my local client settings, so it doesn't really matter about the keyboard layout configured on the server. I'm still going to have the correct layout for my client. With that done, I'm about ready to start customizing my image. Very often, we know what we want done on our images, but we want it done consistently and repeatably correct. So this is where shell scripts can be really useful. But then we have to think of a way of getting the shell script into your operating system. So for this, I'm going to go through and install Git. So with Red Hat Linux systems such as Rocky, I can use the yum install -y and Git. I'm also going to put, though, my favoured text editor, Vim, so I can edit any scripts once they come down. The first time we run sudo, you might be prompted to accept it with respect and then add in your password. This is one of the things that we're going to be looking at customizing, so we don't have to put in a password for our user when we elevate our privileges. This is just for a purpose of ease, but again, you can choose how to customize it the way that you want. So I can add in my password, And we can see then that we're running through the installation, which is adding both Git and my Vim text editor. Now, of course, you don't have to use Vim. There are other editors, such as Nano, you could choose to use. But there you go. That installation is correct and ready to go, which means then that I can clone the Git repository that has my script. So using git clone, HTTPS, I can go to github.com, the Urban Penguin, and once we're there, we can set the repository name, which is just nice and short as VM for virtual machine. Hit the big enter key, allow that to run through, and we are now ready to go. I'm able to move into the directory, and if I do a listing here, you can see that we've got different files, but I'm more interested in the moment in the shell scripts, the .sh files. But I can see there are also Packer HCL files, and we can use these later for creating an image from this operating system. But for the moment, let's go through and take a look inside of our setup_rocky.sh, and we can see the steps that we go through. We're creating an SSH directory within the user's home directory where we can pull down a public key so we can trust the Vagrant private key. This means we don't have to use password-based authentication once we're using this with Vagrant. We can make sure the permissions are set correctly for the authorized key file that we've just populated, and we can make sure the ownership is set up correctly. With all of that done, we're then moving down to the next step where we're allowing passwordless sudo access by creating a new sudo file for our Vagrant user, setting the correct permissions on that. Now, customization that I like because I create a lot of videos, I don't want the beep on tab completion. So this line is just editing the etc input RC file to ensure that we don't have the beep on tab completion. Now we can see here that we're doing an update. We're updating all of the software, which I wouldn't normally want. But if we're talking about immutable infrastructure, we don't want to do an update. We want to keep at this release until everything is tested. So I'm just deleting the update. Then we're installing additional software, as you can see. Now this is software that I would generally use, but again, you might change this list to suit your needs. After the installation of the software, we're actually checking the virtualization that is being used. And we can do that by running the hostnamectl command. It will print the virtualization that is in use. If we're using Oracle VirtualBox, then the hypervisor is going to be Oracle. We need to do certain things to make sure that we've got the guest tools installed for that. Now, I'm using VMware Fusion, so my hypervisor is going to be VMware, and we need to make sure that we've got OpenVM tools installed and the service enabled. I'm setting my time zone now to UTC so that it can be used from anywhere in the world, and I'm enabling my NTP server. We're then clearing up some of the work that we've done. So we're removing any extra packages that have been cached. We're clearing all of the log files. And then we seem to be doing something a little bit strange where we're using DD to create a file. That file will be unlimited. We haven't set a maximum size. So we're going to fill our root file system, but then we delete it. The idea of this, it makes it easier to be able to compress the disk because we filled it with a whole load of zeros, so the disk size will be smaller for our image we create later. We can clear our history, and then we can remove the cloned directory. So I can then go through and close all of this down. I can run my Control and L to clear my screen, just so it becomes a little bit more focused on what we're looking at. And then from here, I can go through and run sudo and bash, and then execute my script. So setup_rocky.sh, And we can see then all of the steps running through. Now we can see when we take a look at this that it's picked up that my virtualization is VMware. It's installing the Open VMware tools, and we're enabling the service. We can see then that we get the error as our disk fills, but then we're good to go because we clear out, we delete the file. So at this stage, we're just about ready to go. But there may be some other customization that we want to carry out. So we've run our script now. We need to be certain that we've got everything done that we need. Now, we were talking about immutable architecture. Now, with immutable architecture, we've installed software at the moment from the repositories, but we don't want updates or new software to be able to be installed. If I go through and just take a look at running the yum update, I'm not going to use a -y because it would go ahead then and do the update, but we'll get an idea of how many updates are available through the repositories. So we're going online, searching those repositories, and we can see there are 41 new packages and 55 packages to be installed. So it's this type of thing that we want to stop. We only want them installed when they've been fully tested and built into our image. So for this, we can go through and say, no, we don't want to go ahead with the update. And we need to make sure now that we can disable all of our repositories. Later on, we can re-enable them in our master image when we want to start updating the image for our next release. But to be able to disable our images, we do need to install some yum utilities. So let's go ahead and do this. So clearing our screen with Control and L and sudo and yum install and then yum utils. We can accept this, so just type Y, and that's then given me the yum config manager. With the yum config manager, I can easily go through and disable all of my repositories. So this is going to prevent any updates. So I can do sudo, let's again use Control and L to move to the top of the screen, and then yum config manager. And then the options that I want to provide for this is to make sure then that I can use -- disable. I can disable a repository by name, but I can use the asterisk to go through and disable everything, but just escape it so it's not picked up by the bash shell. We can then do our yum update, and we can see then that we do not have any repositories. So I can't install software or update software. So we've now got into our correct immutable state. But we can finish off tidying up our system. Obviously, we've run a few more commands, so we might choose to go through and clear our history again. And I can do that with history -C to clear, and then history -W to write that cleared history back to my history file. And then I can go through and power off my system. So sudo and power off. So our image, let's say now, is ready. We've got everything in the image that we need. We can now look at creating our image. Having installed and customized our operating system, we now need to create our image. And we're going to do that with the tool packer from HashiCorp. Now here we are then at our glorious command line, but the glorious command line of my host operating system. So in my case, this is Mac OS. We need to go through and make sure that we know where to locate our virtual machine. Now I'm using VMware Fusion, and if I do a long listing from my home directory, I'm able to list then the virtual machines directory. But there's a space in this, so I just need to escape the space with the \. I can use tab completion once I've got that in, but I've got my virtual space machines.localized directory. And then I can go through and take a look at my Rocky_master. Now this is case sensitive. I set my name in lowercase, but obviously we're going to need an uppercase V and an uppercase M. And when we look in that VMware directory, we can see the VMX file for our rocky_master.vmx. And that's what we're going to be required to point to when we look at Packer to find our virtual machine, so the VMX file. So I can use Control and L again to clear my screen, and I'm going to move into my images directory. And inside of the images directory, I've put my Packer HCL file. This is what Packer is going to use to know how to build my image. And Packer can build images for AWS, for Azure, for Google Cloud, as well as what we're going to be looking at for Vagrant. When I go through and open up this file, the first section that we see is really looking at the plugins that we need to talk to our resources. So we're starting off with a VMware machine, so we're going to need the VMware plugin. And we want to create, if you like, our destination is going to be a Vagrant machine. So we need to make sure that we have those two plugins. Now we can go through the rest of the file, but if I jump out of the file now, to ensure that we have those plugins installed, I can use the command packer, and then we just need to run init, and then reference our configuration file. I can use dot to say, look in this directory for all .hcl files. Now it's coming back with no output, so that just indicates that I already have the plugins installed, so I am good to go from the plugin point of view. But of course, from your point of view, we do need to understand the rest of the configuration file. So we have a source block, and inside of our source block, we're setting up our names. So we're specifying that we're calling this VMware-VMX, and we're using the VMware plugin. The source is where we're now pointing through to the VMX file that we just investigated, and we can communicate through using SSH and the Vagrant user and password. Once we're finished with the system, and we do power it up, but once we're finished with it, we have to then power it off. From this, we're building an image. So we go back to our source, and we can then say that we are reading from our VMware VMX VMware image, the same names that we assigned before in the source block. We can assign a provisioner to run some extra configuration. Here we're looking at a commented out shell script, but we could also run things such as Ansible as our provisioner. And then our post processor, we are now using our Vagrant plugin, and we're sending our output through to the rocky_vmware.box file. And it's the .box file the Vagrant is going to be expecting to find, so we can add it to our library. So that's all the configuration that is required. So I can go through and jump out of that file. We've already looked at the init command, but we could go through and use the validate command to make sure that the file is syntactically correct, and it is, so we haven't made any mistakes. We still might have runtime errors because it doesn't check things such as the path through to the VMX file. But now we know we've got the drivers, we know we have a valid file, we can go through and use packer build. Again, I'm using dot to represent the current directory, and it picks up the .hcl file, and we can see now that we've fired up the virtual machine or a clone of that virtual machine. We check that we can get into the virtual machine. There's nothing we really need to do because we're not provisioning anything, so we can then shut the virtual machine down. I'm just going to move that out of the way so we can see the screen, and we can see then it's just waiting for VMware to tidy up some of the files. Once that's complete, we can see then the files that it did tidy up, and now we're looking at compacting the virtual disk files. So this is why we then populated it with one big file full of zeros and then deleted that file, because we still leave all of the zeros on the disk, so compression is going to be more effective. So we should have our box file now. So I can clear my screen again, and use my ls-lh so we can see the size, and we can see then my rocky_vmware.box. That is my Vagrant file that we can start to utilize. Next, we'll see how to add it to our library. Vagrant is also from HashiCorp, and we're going to see how to add our box file to Vagrant. This allows us then to easily manage our virtual machine and connection to our virtual machine through the Vagrant Virtual Machine Manager. So we have our box file, but it needs to be added to the library. This could be your local library, or you could add it to the Vagrant Up website, the repository on the web. We'll just keep it locally, but we can go through and use the Vagrant command, which is our virtual machine manager, and box add. We need to assign it a name, so we're going through and just going to call it, I normally call my machines local, and then a rough name like R8, and read in the rocky_vmware.box file. So this is then going to copy the file across to the Vagrant library, which means it can be managed by the Vagrant system itself. So as we see, it's copying it across. I could add a metadata file as well to put in versioning, but I'm just leaving that for the moment, and we can see now that we've added that box in. Now, to be able to run a virtual machine, we need a Vagrant file. If I could spell Vagrant, it would help, but let's go through and do a Vagrant init. And then we can say that we don't need a full copy of a file, so we can do a minimal file for the local and R8 file. So it tells me now that it's created the Vagrant file. So this is our configuration file for Vagrant itself that then tells me what machine we are working with. Now that we have that working in the same directory, I just use Vagrant up. So we then clone the virtual machine to create a new instance of it. Gives me some warnings there, just coming from VMware, saying that if we can't get a networking up and running, we might have to define the network adapter to use inside of our Vagrant file. But we can see then the machine is booting up, and now I can go through and just use Vagrant SSH to be able to connect to it. And that's it. We are now in our system. We can double check the host name. Remember that we set this to rocky.example.com, so we can see that that is configured. But of course, it is immutable. We can't change any of the software that has been installed. So if I go through and look at Yum repo list, we don't have any repositories. And of course, if I tried to install extra software, it wouldn't work. But we should be in the correct configuration state now, so there's no reason to change anything. When we do need an update, we can update our original image and create a new instance of our runtime server. And now we can slow down the pace a little bit and summarize a little bit of what we've seen. The idea is that we have been looking at immutable infrastructure. Infrastructure that once is deployed is never changed. Of course, we will need updates, but we don't change the infrastructure in production. We can rebuild our operating system, we can apply updates, we can make configuration changes, but all of that is done offline to the golden image. Once deployed, it is never going to be changed. In this way, we don't find accidents that we haven't located during testing. We started by building our operating system image. Once that had been fully built and tested, we disabled the online repositories, so certainly we're not going to get automatic updates coming through, and new software cannot be added to the operating system. With that in place, we used HashiCorp's Packer to create an image from that. We used the target image to be destined for HashiCorp Vagrant, and we used the Vagrant Virtual Machine Manager to manage the virtual machines. We saw that we could boot an instance of our immutable infrastructure, but of course we were unable to add additional software to it or apply updates.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.